Okay, so this is the first video where we're going to be doing provincial exam walkthroughs for Chemistry 12. So let's begin very quickly and with the first question. Now this is the 2009 exam. I would just like to state that for these exams, they are property of the Ministry of Education of the provincial government, and this is simply for educational purposes, and I'm not affiliated with the Ministry of Education or the BC government in any way. Okay, so let's begin. Which of the following reactions would you expect to proceed most rapidly at room temperature? Okay, so what affects the rate of a reaction that is going to be important for this question? Well, we're going to look at states of matter here, because the states of matter is what's differing between these answer choices. We've got solids, we've got liquids, we've got aqueous species. So let's start with option A. So solids tend to react very slowly, so we're going to rule out A simply because solids typically they react the slowest. That's because they have the least kinetic energy, and if you remember, reactions proceed quickly when there's lots of successful collisions between molecules. Next we have this option, which is H2 gas and Cl2 making HCl. This could be the correct answer choice, but I'm not sure yet, so I'm going to keep looking. This is the next one. So one thing is about reactions between aqueous species when precipitation reactions. Precipitation reactions occur very rapidly. And then option D, what we have is pure liquids reacting. So I'm going to eliminate that. So it's going to be between B and C. So broadly speaking, solids react slowest, then liquids, so pure liquids, then aqueous species tend to react just a bit quicker than gases. So I'm going to go with option C here for the aqueous species. Okay, solid sodium reacts with water to produce sodium hydroxide and hydrogen gas. Okay, so sodium metal plus water goes to sodium hydroxide plus hydrogen gas, H2. So let's have a look at this reaction. Bearing in mind, just this is not balanced yet, so I haven't balanced this reaction. We don't need to for this question. So, which of the following could be used to measure the rate? So we know that rates are measured with respect to time. So, let's have a look. What we need to do is we need to measure something that is changing with time. Volume of the solution is not the best measure because we're making hydrogen gas. That's going to bubble through solution and it's going to leave and escape as a gas. So I'm not going to go with that one. The next option, the pressure of the hydrogen gas. So again, this one is a bit tricky because if we're measuring the pressure of the hydrogen, we'd have to do this in a closed system. And notice we have an open beaker. So we can't isolate the gas to measure its pressure. It's just going to escape. So I'm going to ignore that one. The concentration of solid sodium, we can't measure the concentration of solids. So option D is the only one that remains, and this makes the most sense because as the hydrogen gas leaves, the mass of the beaker decreases. Okay, next one. Which of the following is correct for the activated complex? Okay, so the activated complex, let's have a look first of all what its potential energy is. So this is the activated complex. It's 500 kilojoules. And the next thing is that what's its stability? Well, we know that the activated complex cannot be isolated. It's too unstable. It exists for a fraction of a second. So I'm going to say that option C suits these terms. Low stability and 500 kilojoules. When carbon disulfide, reacts with chlorine gas plus Cl2, 238 kilojoules is released. Okay, so this question is trying to figure out if you know what the difference is between an exothermic and an endothermic reaction, is basically what it's doing. And so let's have a look at our answer options. So in this case, what we have is a reaction between CS2 and Cl2, and we can see that heat is a product, and that means that this is exothermic. So this one is correct. Number 3 and number 2. So in this one, this is endothermic. So that's not correct, because the heat is a reactant. Well, when I say it's a reactant, it's not actually a reactant, but we are applying heat for the reaction to occur. So it's an endothermic reaction. Next is number 3. This is again endothermic because it's saying the delta H is positive. This is exothermic. So the correct answers should be 1 and 4. So should be B. Let's have a look at this one. So we have a reaction mechanism. So 2NO goes to N2O2, blah, blah, blah. Okay, let's have a look at what's an intermediate. Let's start with the easier one. So intermediates are produced and then consumed. So they should be produced, then consumed, and they cannot appear later on. So in this case, our intermediate is going to be what? Pause the video and see if you can figure it out. So we have some potential intermediates here. We have an intermediate here, and we also have another intermediate here. So our intermediates are N2O2 and N2O. Cool. The next one is, what is the activated complex? So an activated complex exists for a fraction of a second, and in this case, these are our intermediates, so they cannot be activated complexes. So we are down to choices C and D. Now the next question is N2 an intermediate? Well, N2 is actually produced, so D is wrong. So the correct answer must be C. So as you can see in this question, we have our intermediate of N2O. It could have been this as well. And our activated complex, which is N2OH2. A student places some hydroiodic gas into a closed reaction container, and then equilibrium is established. Which of the following describes the forward and reverse reaction rates? So we know that initially the rate of forward reaction is higher than the rate of reverse because they have put just the reactants in. So initially the forward reaction is going to be at the maximum, and then the reverse reaction will be at the minimum. Then the rates will eventually equalize. So the rate of forward is going to decrease with time. Then the reverse will increase. And then eventually they will equalize. They have to be equal for it to be in equilibrium. So I'm going to go with A. In which of the containers will equilibrium be established? So we've placed these in separate 1 liter containers, and we want to find which container we're going to reach equilibrium in. Now, what are the conditions for equilibrium? Well, the rates of forward and the rate of reverse are equal. And each of the following, so they're placed in separate 1 liter containers. Nice. Which one do you think it could be? Pause the video and see if you can figure it out. So, let's have a look at container 1. H2 and H2O. Now, these don't react with each other. And the reason that they don't is that we have one reactant and we have one product. What we need for equilibrium is for one of the reactions to occur successfully. So we either need this and this, or we need this and this. One of these two sets. So this can't happen, this can't happen. Let's look at container 3. This can happen because if we put the H2O and the iron, then we will get the reverse reaction occurring, and then eventually when the reverse reactions occur long enough, the forward reaction will kick into place, so they establish equilibrium. Then in this one, H2, H2O, and FeO. So in this case, we have a potential for equilibrium as well. So containers 3 and 4. Next. Consider the following reaction. Okay, and notice we're inputting energy, so this looks endothermic to me. And is there an increase or decrease in entropy? So we have 6 moles of gas, and we have a liquid, then we have a solid, and then we have 6 moles of gas. So in this case, what's happening to the entropy? So the number of moles of gas hasn't changed, but we've gone from having a liquid to a solid, which is a decrease in entropy. So in this case, it looks like the answer is option A, because the enthalpy has increased because we've inputted energy, and the entropy has decreased because we have gone from 6 moles of gas in a liquid to just 6 moles of gas. Consider the following system at equilibrium. Which of the following is correct when the volume of the system is increased? So, let's have a look. Equilibrium shift, amount of N2H6CO2. When you increase the volume of the system, what do you do to the pressure? So when the volume is increased, the pressure will decrease. And so when the pressure is decreased, the equilibrium will compensate to then increase the pressure again. So, let's have a look. The equilibrium is going to shift this way. The reason it's shifting this way is because the gas will increase the pressure. Solids don't exert pressure, only gases do. So the amount of this will decrease by association. So 9 is option C. Some oxygen is added to the equilibrium. Which of the following describes how the forward and reverse rates change as a new equilibrium is being established? So if you increase the amount of oxygen, you increase the rate of forward reaction. That is to get back to equilibrium. So the forward rate should increase or decrease. What do you think? Pause the video and see if you can come up with an answer. So, initially, what's going to happen is we add oxygen, and what will happen is we produce more NO2, so that increases. And so when you have more NO2, what will happen to your reaction rate? Well, your reaction rate for your reverse reaction will increase. So when you're establishing a new equilibrium, your reverse rate will increase and your forward rate will decrease to compensate. Consider the following equilibrium. Which of the following represents the concentration of H2O at equilibrium? So H2O is a gas, so let's have a look. So the equilibrium constant, KEQ, is going to be equal to the concentration of products, which is N2, and then H2O squared, all over reactants, and our reactant is a solid, so we don't include it in the equilibrium expression because it doesn't have a concentration. So now what we do is KEQ divided by the concentration of N2, and then we can square root that, and then what do we get? Well, we have a couple of options that fit that here for the concentration of H2O. Let's have a look. So KEQ divided by N2, all square rooted, so I'm going to get option A. This next question is something that we went over in a previous lecture, and that is, which of the following correctly list the equilibria in order from most favoring products to least favoring products? The larger the equilibrium constant, the more favoring it has of the products. So this one is the highest, so II is the highest. Then we have II mole 3, and then 1. Because 1 is the smallest, it's strongly favoring the reactants. So 1, 3, and 2. So that lines up with the following. Sorry, I may have misread this. Of most favoring products to least favoring products. So the one that favors products the most is 2. 3, 2, 3, 1. 2, 3, 1. Nope, sorry, my mistake. Yeah, 2, 3, and 1. So that should be option C. Which of the following will happen when some NCl3 is added? Notice that they've played this trick. It's that what happens to the value of KEQ? KEQ remains constant. It is not dependent on concentration. It depends on temperature only. Okay, and now when you've added some NCl3, what do you predict would happen? So the equilibrium is shifting left. Because when you increase the amount of NCl3, it will shift the equilibrium to the left to decrease that NCl3 concentration. Consider the following equilibrium. At equilibrium, there were 0.3 moles of BN, 0.2 moles of BCl3, 0.1 moles of N2 in a 2-liter container. How many moles of Cl2 were present? Okay, So let's have a look. So let's write out our equilibrium expression. So BCl3, that's going to be to the power of 2, N2 to the power of 1, Cl2 to the power of 3. Then we do not include this species because it's a solid. So we have correctly written the equilibrium expression, and they want us to solve for the moles of Cl2. So let's rearrange this. So BCl3 squared N2 divided by KEQ is going to equal to Cl2 cubed. So now what we can do, sorry that this is a little bit wonky actually, let me just quickly fix this. Here we go, this is better. And so what we can do is we can take the cube root of that. So we get BCl3 N2 squared all over KEQ. And then we are going to take the cube root of that expression. And when you do all of that, which you can do in your own time, since it will be good practice, you should get option B. Question 15. Which solute will result in a molecular solution? Okay, so a molecular solution, not an ionic solution, a molecular solution. So this will dissociate into ions, H plus and Cn minus. This will dissociate into ions, so barium 2 plus and then 2OH minus. This will also dissociate into ions because what we'll get is this. So the last one is which one doesn't dissociate, so it's going to be this. Alcohols don't tend to dissociate, so ethanol won't produce an ionic solution, it will produce a molecular solution. Which best describes an equilibrium in saturated solution? So the answer to that is B. This is a strictly definition-based question in a saturated solution. Which of the following which compound will have a solubility greater than 0.1 molar at 25 degrees? So for this question, you do have a table of KSP values, so I would suggest that you would actually consult that for this question. So consult KSP table. And what you would do is that you would look at the solubility, the KSPs, and solve from there. So I'll leave this one to you guys to try. What is the net ionic equation between 0.1 molar Na2S and 0.1 molar zinc nitrate? So 0.1 molar Na2S and zinc nitrate. So let's first think about what species are going to be reacting. So we know that for a net ionic equation, we don't include spectator ions. The next thing is we need to know what is soluble and what isn't. So, what is soluble and what isn't? So sodium nitrate is soluble. So in this reaction, what's going to happen is we're going to make an insoluble precipitate of zinc sulfate. So the correct answer is A. And the reason it's A is because a net ionic equation only includes ions that are reacting, not any spectator ions. Spectator ions don't participate in reactions. So, for example, this would not be a net ionic equation. S2 minus goes to Zn S, because this is not participating. So the only things that are participating is this and this, the zinc and the sulfur ion, to make the solid zinc sulfate. Which of the following correctly represents a KSP expression? So a KSP expression is one where we have the correct dissociation equation. So let's start with the first one. AgS to Ag2 plus S2 minus. And so silver is 1 plus, so actually I should fix that. Ag2S, silver sulfate. So it'll be 2Ag plus S2 minus. And our KSP expression will similarly have to represent that. So then our KSP is equal to Ag plus squared and then S2 minus. That's our KSP. We don't include this because why? Because it's a solid. So this option looks correct. Let's look at the other ones. Okay, in this one, we have barium nitrate and they've included the solid, which is wrong. Again, calcium oxide, it's a solid, so we've included that. So, and they've also calcium carbonate, it's somewhat soluble, so that should be Ca2 plus CO3 2 minus. This is just wrong because they've just included the ions on the bottom when they should be on the top. So this one should be like this. And as you can see that they've flipped the equation, so the KSP should actually be like that. Cl minus squared. What is the solubility of the salt? Lead sulfate. So I'm going to show you how to do this one, but I won't plug in the numbers so that you guys can practice. So for some of these questions, I will get you guys to just, have a go at them, as that's just really good practice for your exams. So lead sulfate, let's see. So Pb 2 plus, SO4 2 minus. Okay, PbSO4. So I'll remove that for a second. And so the KSP expression, that's the KSP. And then x squared is equal to KSP. We get that from our ice table. And so x is equal to the square root of KSP. What is the maximum concentration of I minus that can exist in the solution with Pb equals 8.5 times 10 to the minus 3 molar. So have a go at this one yourself. Which of the following occurs when 0.1 molar HNO3 is tested? So it's an acid. So if it's an acid, it's going to turn at the indicator a specific color. And in this case, what happens? It's going to turn our indicator bromethymol blue to yellow. Phenolphthalein turns pink when the pH, it turns pink, pale pink, at the equivalence point of a titration. So bear that in mind. Which of the following is the Bronsted-Lowry base for the forward reaction? So, a Bronsted-Lowry base is what? A Bronsted-Lowry base and a Bronsted-Lowry acid, they're in pairs. So acids have a proton that they want to give away. So this is the ammonia. It's got an extra proton. Notice the positive charge. And then we have HCO3 minus. So we have an O minus. So HCO3 is what we have here. So we have our carboxylate. It will grab that hydrogen. And then this is what's happening. So our Bronsted-Lowry base is the one that takes the proton. Notice it becomes its conjugate acid. So the conjugate base must be this. For NH2 minus, well, all you have to do to find the conjugate acid is to add a proton. So it's NH3. Which of the following is characteristic to all strong acids? Well, strong acids are, this is not necessarily true, you can have dilute strong acids, but the actual correct answer is that they ionize 100%. That's what makes an acid strong, because weak acids, we give them Ka values, and the Ka values are typically less than 1. That's because they don't ionize 100%. Which of the following represents the behavior of a strong Arrhenius base? So, a strong Arrhenius base will dissociate fully in solution. That's how Arrhenius define them. So we're not going to use C and D because those are in what we call equilibrium. Next, we have the next couple of options. So in this one, this is not a dissociation. It's just gone from one solid to another solid. So the answer is B. Which of the following represents the ionization of water? So the ionization of water is an interesting phenomenon, specifically in the sense that water will convert into H plus and OH minus. That is the auto-ionization of water, is what we call it. So which of the following equations is going to represent that? Have a go. So I am leaning towards a certain answer option here. Let's see if you get the same one. Give you just a couple more seconds before I actually fill in the answer option. So the auto-ionization of water is going to be option B. So when water dissociates, it has a ionization, and that value of the ionization constant is 1 times 10 to the minus 14. The ionization of water is endothermic, which of the following is a reasonable kW if the temperature of water is greater than 25 degrees. So here's what's happening. That has a kW of 1 times 10 to the minus 14. If it's endothermic, then what will happen to the value of kW when the temperatures increase? Well, kW should increase as temperature increases because the forward reaction is endothermic. And so, in this case, we should see an increase in the kW. So this is the original value. That's at 25 degrees, not this one, because these are both less, so it should be D. What is the pOH of 0.25 molar HNO3? Okay, so let's have a look. So what is the pH, first of all? So pH equals negative log H plus, so it'll be negative log of 0.25, which is the pH. And so 14 minus the pH will give us the pOH. And so notice also that we have a strong acid. So if the pH is high, then when we calculate the pOH, so the pH is low, we're calculating the pOH, we should get a number like that, D, because it's a very strong acid. Which of the following expression for the predominant equilibrium in HPO4? So HPO4, 2 minus. Is it an acid or is it a base? One question we can ask ourselves. So HPO4 is more of a base than it is an acid. So what's going to happen here is the following. It will react with water and it will make H2PO4 plus OH minus. So that will give us option B. notice they're asking for an equilibrium constant expression, which is products over reactions. And remember, we don't include pure liquids in the equilibrium constant. Which of the following 0.1 molar solutions will have the highest pH? So the highest pH, so the most basic. So we have HNO2, we have CH3COOH. So what we have here is, this is an acid, this is an acid, this is also an acid. This will have the highest pH. And again, it looks like what we have is potentially all of them are acids. So which one are we going to choose? So we're going to choose the weakest acid to have the highest pH. So that's the diagram of HNO2, just for your information. And so, in this case, our weakest acid should be here. This is strong. This is still weak, but it's stronger than H2S. Nice. 32. Which of the following describes the predominant hydrolysis reactions that occurs in KHCO3? KHCO3, K plus, and HCO3 minus. Yep. So we have the potassium positive ion, and we have the bicarbonate ion. So potentially, but let's keep going. Okay, so we have two potential equilibriums that I can see from the top of my head. Either this one, or we can have this one. Because HCO3 and H2O, they can react, and this hydrogen carbonate, should I say, ion, the bicarbonate ion, is basically going to be reacting with the water. So it looks like, in terms of equilibrium, that this is going to be occurring the most. Which of the following represents an acidic salt solution? In this case, only acidic compound is here, 33. That answer choice should be B. A chemical indicator changes color at its what? Transition point. This is just a terminology question. Which of the following could be the approximate pH of the solution? So I'll leave this one to you guys, because this will tell you, because you need to figure out the range in which they change pH. Which of the following represents the complete ionic equation for the reaction of hydrochloric acid with NaOH? Well, when hydrochloric acid reacts with NaOH, it will first react with the H plus and the OH minus. Those two are going to be reacting. And it's the complete ionic equation, so we want all the ions. So what do we have? We have Na plus, we have OH minus. It's not asking for a net ionic equation, because this is the net ionic equation. So H plus and Cl minus. So H plus, Cl minus, Na plus, OH minus. So it looks like this is the correct answer, because we've got all the ions, including spectator ions, sorry. Which of the following would show the result of adding a small amount of HNO3? So if we add a small amount of HNO3, we add an acid, which contains Cn minus. So what will happen in this case? When you add I misread that, HNO3. Sorry. So, when you add HNO3, what's it going to react with? Well, it's going to react with a base. So the concentration of Cn minus will be changed by the base. So this will decrease when it reacts with the base, and then the rate of the forward reaction will increase to compensate. So then what will happen is that when you add this to the buffer, the concentration of Cn minus should increase slightly. The reason it increases is because although initially it decreases, the reaction will shift to the right to increase it. Which of the following elements will form a solution that only acts as a base? So the alkali metals are the only things that are going to be making solutions that are basic here. Which of the reduced substance in a chemical reaction can best be described as a substance that is, well, something that gets reduced? It's an oxidizing agent, right? And what happens to the oxidizing agent? It oxidizes something else, so therefore it must gain electrons. If something else is being oxidized, then something else must be reduced. The oxidizing agent, the reason we call it an oxidizing agent is because it becomes reduced. So the oxidizing agent becomes reduced. A common example of that is potassium permanganate, which is a strong oxidizing agent. Okay, so we've done the first 39 questions, and we still have remaining around the last 10. So we'll go through those in another video, but here are all the data tables that you'd probably need, and then we will move on to some of the written responses.